Hello everyone, I am Sibendra Singh. Today I'm gonna discuss a past year problem of ISI B.Stat.B.Math entrance examination. Uh, this is the question. It says that an is a sequence of real numbers defined as an plus 1 is equal to this thing for all n greater than equals to 1. We have been given two cases. First, 0 less than a1 less than 1, and second, a1 is greater than 1. We need to prove that in the first case an is increasing, and in the second case an is decreasing, and then so that the limit n tends to infinity an is equal to 1 in both of the cases. In this problem we'll be using a very famous theorem. uh, Without proof we'll just be using, and so I mention here it as Bolzano-Weierstrass theorem, and it states that every monotone bounded sequence has a finite limit. That is, if the sequence is monotone, either increasing or decreasing. Just like, for example, in the first case, uh, the sequence has to be increasing. We'll prove that also, and in the second case, it will be decreasing, and then so that the sequence, both of the sequence, in both of the cases, the sequence would be bounded. So after showing this, we can assume that the sequence has a finite limit according to the Bolzano-Weierstrass theorem. So we will show that in this case the sequence is both bounded and monotone. Okay, so let's proceed ahead. In the first case, we have been given 0 less than a1 is less than 1, and an plus 1 is equal to 3an divided by 2 plus an for all n greater than equals to 1. First, we show that we will show that 0 less than an is less than 1 for all n greater than equals to 1. uh, by induction. We have 0 less than a1 less than 1, so let 0 less than ak less than 1 for all k is equal to 1 to delta dot n. So an plus 1 is equal to 3an by 2 plus an. This can be written as 3 by 1 plus 2 by an, right? Uh, so by the induction hypothesis, 0 less than an is less than 1. This means that 2 by an let's write in the next page. 0 less than an is less than 1, so 1 is less than 1 by an is less than infinity, right? This implies that 3 is less than 1 plus 2 by an is less than infinity, or 0 is less than 3 by 1 plus 2 by an is less than 1. check this. This is a very simple calculation. So you get 0 less than n plus 1 is less than 1. So by induction, uh, if the hypothesis is true for all k from 1 to n, then it is true for n plus 1th term. Hence, by induction, 0 less than n is less than 1 for all n greater than equals to 1. Right? So we have shown that this sequence an is bounded. Next, we need to show that the sequence is increasing, right? It was the case for increasing. Okay. Increasing. So for this, an plus 1 is equal to 3an by 2 plus an implies that an plus 1 by an is equal to 3 by 2 plus an. Since we have already shown that 0 less than a1 an is less than 1, which implies that 2 is less than 2 plus an is less than 3, or 1 is less than 3 by 2 plus an is less than 3 by 2. So we use this thing. And what is 3 by 2 plus an? So 1 is less than an plus 1 by an. This implies that an plus 1 is greater than an for all n greater than equals to 1. So an n greater than 1 is monotone increasing. Hence, we have shown that an is both bounded and monotone. So by Bolzano-Weierstrass theorem, an has a finite limit, say L. Okay, that is limit n tends to infinity, an is equal to L. So if n tends to infinity, then obviously n plus 1 will also tends to infinity, and this will also be L, right? So if n goes to infinity, an will go to L, and an plus 1 will also go to L, right? Therefore, we have an plus 1 is equal to 3an by 2 plus an. So, L is equal to 3L by 2 plus L as n goes to infinity, right? So, this will be L times 3 by 2 plus L minus 1 is equal to 0. Since we have shown that an is increasing, so limit n tends to infinity can never be 0, right? Therefore, 3 by the other option, this must be 0 or L is equal to 1. That is, this is equal to 1. Okay. Now in the second condition, we have been given a1 is greater than 1 and an is, and we need to show that an is decreasing and limit tends to infinity. N is equal to 1. The process is very similar to the one we did now. There, once you solve that, I'm giving you a hint here. Uh, once you will get that everything, right? You first you have been given uh, a1 is greater than 1, right? So as you proceed, you will get that 1 is greater than each of the quantity which is greater than an is greater than an minus 1 is greater than a1. So this thing will be observed after you solve as similar in this very similar way as we have shown here. As we have shown here that it is monotone increasing, there you will get this way. This is monotone decreasing. Since a1 is also finite, I mean, yeah, and 1, so the sequence an, you will get that here again is monotone decreasing. The process is very similar and is bounded by a1 on as a minimum or infimum, perhaps minimum, and 1 to be the supremum or maximum, for instance. So you'll get again limit as to infinity an is equal to this quantity exists, okay, by Bolzano-Weierstrass theorem, and you may assume this to be L. So you get the same conclusion as you do here. An plus 1 is equal to 3an by 2 plus an. So this is L, this is L. Repeat the same process. You will get limit and tends to infinity an is equal to 1. Now try to solve this as an exercise. The process is very similar to the one we did here. Okay, then thank you.